Now, this question looks like a question of time and work from pipes and systems, but actually, no concept of pipes and systems is required to do this question. Okay, you can make just simple equations, equate them, and get the answer. Now, there are two containers P and Q. Q is half filled and P is one third filled. Now, when tap is connected to each of these containers, P takes 9 hours to fill it when it is empty. So total time taken by P to fill is 9 hours, and Q takes 15 hours to fill it when it is empty. Now different taps are connected, different taps with different efficiency are connected. It might be possible. Also, the volume of P is more than that of Q by 50 percentage. So this is the data that is given to us. Okay. Then find the time after which the volume of water in container Q will become 30% less than the volume of water in container P. Okay. Now let's begin with the some assumptions. So first of all, it is given that tank P, container P and Q. Q is half filled, so it is already half filled, and P is one third filled. Now, when tap is connected to P, it takes 9 hours. So P gets completely filled in 9 hours and Q gets completely filled in 15 hours. Also, uh, the capacity of P is 50% more than that of Q. So I can start by assuming the capacities in terms of liters for both Q and P. Okay. So I'll assume the value for Q as 90 liters for the ease of calculations. Now, since the capacity of P is 50% more than that of Q, so the capacity for P will become 90 plus 45, that is 135 liters. Okay. Now, P is entirely filled by the tap in 9 hours. So 135 liters in 9 hours. So the rate at which the water is filling in tank P is 15 liters per hour. Similarly, for Q, it is 90 divided by 15, that is 6 liters per hour. Okay. Now, the total capacity of P is 135 liters, and it is given that P is already one third filled. So the quantity of water that is already present in P is 135 divided by 3, that is 45 liters. And in Q it is 90 divided by 2, that is again 45 liters. So in both the tanks, in both the containers, already 45 liters of water is present, right? Now, let's assume that the given situation arises after T hours. Okay, so the position of P after T hours will be 45, which is the present quantity, plus 15 times T. And for Q, it will become 45 plus 6 times T, right? At this moment, we have to find out what will the volume of water in Q will be 30% less than the volume of P. So volume of water in container Q is 30% less. That means it is 70% of the water in P. I have made the equation, just solve it and find out the value of T. Okay, so first of all, 5 can be cancelled. So 2, 9 and 3, 63. Can I cancel anything else? Yes, I can cancel 3. Okay, so let it be. So 7 into 9, 63 plus 21T is equal to 45 into 2, that is 90 plus 12T. Now simplifying, I'll get 9T is equal to 27 and the value of T comes out to be 3. So I can say that after 3 hours, the volume of water in container Q will be 30% less than the volume of water in container P. So the correct answer for this question should be option B, that is 3 hours. Pretty easy question it was, though it was lengthy, but such questions generally what examiner will do is they would like to add up the complexity just by increasing the length of the question. Okay, so let's move on to next question, question number 16.